Today we're going to move on to 4.7. This section is called Use Congruent Triangles. So our goal for today is to prove two triangles are congruent and use that idea to go on and prove another item within the triangles are congruent. Okay, so let's just kind of step through this first one. We are given that AB is parallel to DE. So I'll put the parallel marks. We are also given that AB is equal or congruent to DE. So not only are they parallel, they're congruent. We're trying to prove that C is the midpoint of BE. So this is a little different for us. Normally it says prove triangle, whatever, ABC is congruent to DEC or whatever the order is. Now, I'm going to prove that at the very end. Okay, so this is the end. So this cannot be used in my proof. So kind of ignore it for the moment. What I need to do here, like what I'm kind of thinking about, is I need to prove that the triangles are congruent. Okay, so I'm still going to do my normal look for things I can mark on my diagram and show the triangles are congruent. So let's just talk about what we see. I mean, there's a couple ways we could go about this, but I'm going to focus on the parallel lines. If my lines are parallel, I see that B and E are congruent, and I see the other set of angles here are congruent, all by alternate interior. So I'm just going to do I'm just going to jot down here that B is congruent to E, and I also showed that angle A is congruent to angle D. Both of those were by the alternate interior angles theorem. Okay, so that gave me enough to show ASA. All right, so I just went through and I showed that ASA was happening. And what was happening, and I guess I should actually be a little bit more precise, I just proved that triangle ABC is congruent to triangle, let's see, if it's ABC, it's going to have to be DEC by ASA. Okay, now let's get back to what we're trying to prove. Now that we have shown that the triangles are congruent, I want to go back to the basic definition of congruence. Once you know the triangles are congruent, you know all the corresponding parts are equal as well, because that's the basic definition of congruence. Even though I technically just talked about an angle, a side, and an angle, now that the two triangles in total are congruent, all their parts are equal. Okay, so I'm going to make a sentence here. Let's write this down. I'm going to say, since the triangles are congruent, all corresponding parts are congruent. Okay, all corresponding parts are congruent. Okay, so what that means is I can now go on, and let me change up my colors here. I can now go on to say, even though I didn't talk about this in the proof, I know that BC is congruent to CE. Okay, and I know that because the triangles are congruent. All of their individual pieces are congruent. I also, for that matter, know that AC is congruent to CD. So I can go on and I can say that BC is congruent to EC because, and I'll talk about in a minute why that is. And then I can go on and say, well, if I know that those two are congruent, I can show that C is the midpoint of BE by definition of midpoint. Okay, but I want to focus back on this piece right here. What would I say in my proof? Well, I would basically summarize the sentence above. I would basically say, well, since the triangles are congruent, all of their parts are congruent. And so what we say here, here's what we're going to say, but we're going to shorten it with an abbreviation. The reason BC is congruent to segment EC is because that the corresponding parts of congruent triangles are congruent. Okay, and so we're going to shorten that even further to an acronym. So we're going to call that CPCTC. And acronyms are only as good as they make sense to you, okay? So the first C is the word corresponding. Okay, and so the acronym's coming out of that, what I wrote down here. So corresponding parts, we'll kind of skip the of, congruent triangles, the word are gets booted, and then congruent. Okay, so we have corresponding parts of congruent triangles are congruent, CPCTC. So in a proof, that's what I'm going to put on the statement side. Okay, so it's still, I guess, business as usual. We still are constructing a proof to prove triangles are congruent, but then we're going to be asked to prove one additional item, and most of the time we're going to be able to prove that item by saying corresponding parts of congruent triangles are congruent. Okay, so let's start with the next couple examples explaining what are the triangles we're trying to prove congruent and why. Okay. Tell which triangles you can show are congruent in order to prove the statement, what is the postulate or theorem? Okay, so this is saying which two triangles are congruent in order to prove this. So this is sort of like in my proof, this is the prove line. Okay, this cannot be used in my proof. Okay, so I'm kind of like ignoring that. That is not part of any given or anything like that. So I'm going to do what I did above. I'm going to come up with, I'm going to name the two triangles and come up with my reason. Is it SSS? Is it HL? That type of thing. Okay, and we're not making a proof. We're just sort of informally getting there. I see an angle, I see a side, and I see a reflexive. And so I now have side angle side. I have SAS. So the question says, what are the two triangles? So I can prove, and this is where you can name your triangles differently than me. They just have to be in a corresponding order together. So I'm going to call this one JKM is congruent to. So that means I need to say LKM. And the postulate or theorem I used was SAS. Okay? Now, if I were to go on and prove what I highlighted, I would say, well, that's congruent by CPCTC. This corresponding parts of congruent triangles are congruent. But the question really just asked for this. Okay, I would like you guys to go to the next page and do example 2. It's just like example 1, but just a different diagram. So pause the video and come back when you're finished with number 2. Okay, I see a set of angles. I see a set of sides. All right, I have parallel lines. So I'm going to be able to grab my corresponding angles here. And so my triangles I'm going to prove congruent. I'm going to call the top one PRQ. It's congruent to RTS, and we were able to use angle, angle, side, AAS. Okay. All right, let's get into 2 proofs here. So if you would go ahead and start your columns, we're going to see what it looks like to prove this. Let's see. I'm going to, I guess, start over here. Got statements and reasons. Now, the givens are the marks on the picture, okay? So let's write those out. So I have segment SV is congruent to segment TU. I also have segment ST is congruent to segment VU, and that's just given because it's marked on the diagram. Okay, so we are trying to prove this. That goes at the very end. So we're going to ignore that for a moment because it has nothing to do with what we're going to do next. We need to prove the triangles are congruent without doing anything with S and U. So look at the picture. I see a reflexive. Let's mark it. So number 2, I'm going to be able to say that VT, segment VT, is congruent to segment VT. That's going to be the reflexive property of congruence. And I have the triangles congruent now. I can see I now marked SSS. So now you've got to name them in an appropriate order. So just name your first one and then make your second one match how you named the first one. So I'll go SVT, triangle SVT. That would be congruent to UTV. Right, I went through, I like to look at the marks I go through. So I started with S, went through the single mark, went through the triple mark, and then I started with U, went through the single, triple, yeah. And so 3 is side, side, side. Now we're ready to prove. Now that we've shown the triangles are congruent, every little piece is congruent, okay? And so now, let me not do red, let's do pink. Now I do know that these two are congruent because all the corresponding parts are congruent. So I can end my proof with angle S congruent to angle U. And so you can use the acronym CPCTC, or if you want to just write a short phrase, you can abbreviate. So we could write corresponding parts of congruent triangles are congruent. Okay, you could write it out like that. And that might make more sense to you than some random acronym that in a month from now you're not going to remember what it means. All right, so this is what a proof would look like if we were showing like angles or sides are equal. All right, let's do one more. So let's get our diagram all set up and see how far we can get here. I would like you to see how far you can get and then come back to the video when you get stuck. So I'm writing angle N and angle P because N is not a part of any other angle and neither is P. So if your vertex of your angle is a standalone angle, then you could use the single letter name. There's absolutely nothing wrong with using the 3-letter name. Segment NP, congruent to segment PQ. Those are both of my givens. Okay, what else do I see? Oh, vertical angles. So I'm going to mark vertical. And as I mark it, I look, does that give me one of my foldable shortcuts? And yes, I do. That gives me angle, angle, side. All right, because sometimes you might notice vertical is true, but it may not help you get to your answer. So I'd like to think about that before I go too much further. Okay, angle L. Now I do need the 3-letter name. So I'll name the top one angle NLM. And then I can name the bottom one PLQ. And then vertical angles, vertical angles theorem. It's also sometimes called vertical angles congruence theorem. That's fine. Okay, my triangles are congruent, so it's time to name them. So triangle, and I might be able to go in the same order as what I did on step 2. We'll see. Triangle NLM, I'll start out that way, is congruent to LQ. Because when you name angles, the first and last letter, the order doesn't matter, but when we name our triangles, it will if they're congruent. Okay, and we said this was angle, angle, side. Now let's show this is true. Notice it's not marked on the diagram. It shouldn't be because we're not using it in the proof at all. Okay, now those two sides that are not part of the proof are congruent because the corresponding parts are all congruent. Okay, so number 4, I'm going to be able to finish with what I'm proving. Segment LM is congruent to segment LQ. And then again, if you want to do CPCTC, that's great. Or you could write corresponding parts of congruent triangles are congruent. You can do it that way. Okay, so that is, I like to think of this as an extension of the proofs we've been doing. So we're just going to continue to do more proofs, and I hope you're, at this point in the unit, becoming a lot more comfortable with these. If not, let me know, and we can go through and I can try to help you if you've got areas that you're stuck on.